So this is work, energy, and power. Work, energy, and power. Work, energy, and power, right? So I'm not going to focus much on theory. I'm just going to be strictly focused. You can find everything on my classes. We are going to do this topic this weekend. So question 7 is, in the diagram below, a small object of mass 2 kg is sliding at a velocity of 1.5 meter per second down the horizontal and down the rough plane inclined at 10 degree to the horizontal. So this is more like Newton's laws. And I believe with a learn, because work energy and power is more interesting and more challenging at the same time. All right. So look at this. I have a velocity of my own object at the incline. Right. I have velocity there of 1.5. Then let's continue. At the bottom of the plane, the object continues to slide on the rough horizontal surface. So that means it comes to stop, then which means it has stopped somewhere we don't know. Then the frictional force acting on the block while it slides along the inclined surface is 2.5 Newton. This is the friction of the block while it is sliding on the incline. All right. Then the coefficient of kinetic friction between inclined surface and the horizontal surface, which means the coefficient of kinetic friction is the C. Because if they didn't tell us about this statement, we safe to assume that coefficient of kinetic friction is different, because you know from Newton's law, coefficient of kinetic friction depend on the type of surface. Right. So let's go to the question. We have 7.1. We have two types of forces that you will learn in this topic. We have consecutive and non-consecutive forces and non-consecutive force. Right. So for non-consecutive force, this is a force for which the work done in moving an object between 2 points depends on the. Basically saying this, it's much more like dealing with friction, right? Friction depends on the type of surface. You guys won't understand this. Let me make an example of non-consecutive forces. And this is my point B. So this question implies that for consecutive force, conservative force, for consecutive force, either if you are moving this way from A to B, or you are using this way to move from A, equal for both scenarios, because it is independent of the path taken. That is where we talk about a surface with no friction, a smooth surface, something like that. Things like gravity, and in fact, the non-contact forces are the consecutive forces. But things like friction and they are part of non-consecutive forces. They depend on the path taken. If you are using, let me draw another diagram there. You are moving from A to B. If you are using this way, or you are using this way, the work done, they're not going to be A to B. That is what non-consecutive forces implies. It depends on the path taken, right? I won't go much in detail. So the work done, or force for which the work done, for which the work done in moving an object between 2 points. All right, that's it. So that's your definition is 2 marks, right? And then 7.2 says draw a labeled free body diagram for all forces acting on the block while it is on the inclined surface. So we need to draw the free body diagram for this one, right? And then what I mostly advise is so diagram of the incline itself. That help you to know the direction of the normal force and the direction of the weight. Because weight is it is always going downwards like that. All right. Weight is always going downwards like that. The normal force is perpendicular to the surface. This is a force that acts perpendicular to the surface. Then again, you have friction right there, which is going to is much more like that. Much more like that. So you are going to have your free body diagram being like this. Uh, and then this is your FK, and this is your weight, this is your normal force. Simple as that. There's nothing complicated, nothing hard. You just energy theorem in words. So the work energy theorem in most cases in physical sciences, if they ask you to determine a law, a definition or something, you are most likely to apply that thing, especially principles. When they ask principles, you have to use those principles, or you are more likely to use those principles underneath. All right. So on an object is equal to the object change in kinetic energy. Mm, okay. The net. This is not Vodacom network. Some of you are thinking about networks. You guys are more likely focusing on social media than your studies. The moment I said network, someone is interested whatsoever that you guys are using, right? The network done on an object is equal to the object's energy, kinetic energy. And this principle also comes in a formula which says W net is equal to change in EK. All right, that's it. So let me plug my laptop before it interrupts everything. Right. Um, good. Okay, so listen. We're moving now to 7.4. I want to explain the principle. I want to explain it to you. I want to explain it to you at all. So they said use the principles or use energy principles to come at point B. Hey guys, listen carefully to the question. They said use energy principles. So you can use equations of motion as long as you involve also energy principles. You are free to do that. What only you're not allowed to do is where they said use energy principle only. That is where you strictly focus on work on energy principles more with equations of motions, right? So they want us to use energy principles to calculate um, the velocity of the block at the bottom of the incline. All right. So let me move up here and see if I can squeeze this in. Let me move up here. Want to. All right. So let me erase. Amba. Amba. Why doesn't it want to move or to leave? All right, all right, all right, all right, all right. All right, so I think it's just being slow itself. So it will waste our time either way. It's going to waste our time. Straight, big. All right. So what you can realize, we're going to use energy principle, or yes, energy principle. I'll write it at the bottom, by the way. So the energy principle that we can use, I think it's um work work energy theorem itself, which says W net is equal to, should I use W net? Yes, let me use W net is equal to change in EK. You can also use for the non-consecutive, you can apply it. Just that for you, I don't think you know about it just yet. So I'll only do one option. All right. So in this case, you're going to ask yourself, what is my W net made up of? My work for gravity, which is Fk, plus work for Fg parallel, because that is on the incline, right? Work done by force of gravity parallel. Then you're going to have change in Ek, which is equal to 1 over 2 mv squared. It should be final minus 1 over 2. And it is squared right there. So, W or work done is equal to F delta X cos of theta. That is the formula, right? So we were given the magnitude of friction there, which was 2,5, right? And then it's going to be multiple. What was the distance? Were we given the distance? No, we were not given the distance, but we can express the distance in terms of 5 meter and the angle, right? Because this is a right angled triangle. And in a right angled triangle, we have ratios. So this is my hypotenuse. This is my hypotenuse. I want to express it. Opposite. So it's going to be opposite over hypotenuse is equal to psi 10 degrees, right? So all in all, when you work a calculation, h is going to be equal to 5 over psi of 10 degrees. That's it. So this is your distance. It's your distance right there. So you 2,5 multiplied by 5 over psi of 10 degrees. Right. Then multiply by cos 180. 108 should be, yeah, should be 108, because a friction working negative work, it is opposing the motion. So when it opposes the motion, we use 180, and 0 when it is supporting the motion. I'll do those in the lesson. I'll explain more in details. So just for summary, when it is opposing the motion, it is cos 180. When it is supporting the motion, it is cos of 0 degree right there. Fg is equal to 2 multiplied by 9.8 multiplied by my distance. Again, my distance is going to be, for this one, my distance will be, let me check. Wait. I will do parallel. I think for this one, I can use my distance as 5 meters, because 5 meters, it is basically delta y for, it is basically delta y, and then gravity But also you can use the same distance. If you don't want to confuse yourself, you can use the same distance as this one. Okay, rather let me use this one, in fact, not to confuse you. It's going to give us the same thing of what I was talking, just that one you won't understand. Simple. Sine of 10 degrees, right? And then it's going to be multiplied by theta for FG. FG parallel is equal to FG sine theta. That is the formula itself, right? So I'm also going to multiply by sine 10 degrees right there. You see? And then if you check correctly, I'll show you what I was talking about. I'll show you definitely. And then you further multiply by cos of 0. Because force of gravity is always going downwards. Even FG parallel, it is always going down the incline. So I'm going to have 1 over 2 into 2. What is my final velocity? I don't know. I'm looking for it. So I'm going to say VF squared minus 1 over 2 into 2 multiplied by what velocity was 1,5. 1,5 squared. So now look at this before I forget. Because the two are multiplying, 5 over sine of 10 multiplied by sine of 10, I can cancel the two. I can cancel them. So I'll be left only with 5. So it comes back to this. Right. So now let me go to my calculator. Yes, now I have you calculator. 5 over sine of 10 degrees. Close brackets. Because 180 is equal to -1. I know that. So 1,98. I'm going to round into 2 decimal places not to waste my time. Again, I'm going to multiply 2 times 9.8 multiplied by 5 multiplied by cos 0 is going to be 98 plus 98. And cos 0 is basically 1. Then 1 over 2, I will be left with VF squared right there minus what is 1 it's basically 2 and 2, they're going to cancel each other here. 2 and 2 cancel and cancel. I'll be left with 1 over 1,5 squared, which is basically 2,25. 2,25 right there. So I'm going to VF. So I'm going to say VF squared is equal to negative 71,98 plus 98 plus 2,25 right there. So I have 28,27. I have VF squared now, but they want VF or the final velocity or velocity at point, or they want the speed. So you know the square root is plus or minus, right? So I'm going to have plus or minus 5,32. But because they're asking for the speed, I'm going to have VF as 5,32 meter per second right there. So that is my answer. Now you get it in this topic. So I will stop from here. I think I've summed you.